Today we are going to continue our study of Science Chapter 7, Understanding Weather, with Lesson 2, Air Masses and Fronts. We have 4 objectives for today's lesson that you should know by the end of the lesson. You should be able to identify the 4 kinds of air masses that influence weather in the United States, describe the 4 major types of fronts, explain how fronts cause weather changes, and explain how cyclones and anticyclones affect the weather. So here are the 4 air masses that affect weather in North America. We have the Maritime, which is represented with a lowercase m. Mara is like a prefix for water, so this means that it forms over the water. Therefore, it has a lot of precipitation, so it's wet. Continental, represented with a lowercase c. It forms over land, so therefore it is dry. Think about a continent as land. Polar, represented with a capital P. It forms over the polar region, so it's cold. And tropical, with capital T, develops over the tropics. Therefore, it is warm. So you combine these 4 terms to give you the different air masses. So we have a maritime polar, we have a maritime tropical. We have a continental polar, continental tropical. And here's maritime polar and maritime tropical again on both the east and the west. You're going to go back and watch the study jam on air masses and fronts. So our changes in weather are caused by the movement and the interaction of different air masses. So here we see that an air mass is a large body of air where the temperature and the moisture content are constant throughout. Most of the cold winter weather in the United States is influenced by 3 polar air masses. And then there are 4 warm air masses that influence weather in the United States. Here we have a cold front and a warm front, and this shows you the direction that the front is moving in. So both of these are moving from left to right. So we have a cold air mass and a warm air mass. Same here, but let's look at what is happening. So a front is basically an area in which 2 types of air masses meet. So 2 different types, like a cold and a warm. So a cold front forms where cold air moves under warm air. And we know that warm air is less dense, so this cold air mass is going to push the warm air up. So this is therefore a cold front. Cold air moves under the warm air, pushing it up. This would be a warm front. A warm front forms where warm air moves over the cold, denser air. So the warm front takes over in a warm front. The warm rides over because warm air rises, remember, cold air sinks. It's more dense. Here, the stronger of the 2 is the cold air mass. It's going to move under the warm air mass and push it up. So we have a cold front. There are occluded and stationary fronts as well. So an occluded front, if you'll look at it, it looks rather confusing. An occluded front forms when a warm air mass is caught in between 2 colder air masses and has cool temperatures and a bunch, like a lot of rain and or snow, depending on what the temperature is. So it's like it's being sandwiched. It's occluded, and that's just a weird word, and it just looks like a big old mess, which is really what it is. Stationary front, well, stationary means it's not moving, staying still. So a stationary front forms when a cold air mass meets a warm air mass, and neither one of them are really, it's like kind of like they're equal. It's kind of like tug of war. So you just have days upon days of this gloomy, cloudy, wet, icky weather. It's just a day. All right, so your cold front, your warm front, your occluded front, which is all messed up, and your stationary front, where it just sits and stays. So let's deal with air pressure and weather for a second. Let's start with a cyclone first. A cyclone, you can think of it like a tornado or hurricane. It's an area of low pressure, and it moves counterclockwise because we're in the northern hemisphere, remember, due to the Coriolis effect and the spin of the Earth. So counterclockwise. An anticyclone is opposite of a cyclone. So if a cyclone has low pressure, an anticyclone is going to have high pressure, and it's going to move clockwise, just the opposite of the cyclone. So a cyclone, low pressure, anticlockwise. Anticyclone, high pressure, clockwise. And you kind of have to trick your brain because you kind of want to put anti-clockwise with anticyclone, but it's not that way. Okay? So this is the end of lesson 7.2. The next time we will begin our lesson dealing with severe weather.